Hello, Not Manly here, and welcome back to Kerbal Space Program, where we're taking Derek Kerman here out for a joyride. He's asked us to basically invoke a G-lock, make him unconscious while flying a high-performance craft. If you have Kerbal G-forces enabled in your career playthrough, these kinds of contracts are an option. And here in the very thick atmosphere of Eve, it does not take much to get some pretty high G turns. Look at that. Just about 15 Gs. We almost got it there. We didn't quite get it. Derek is like, oh my goodness, this is what it feels like. No. And there we go. He's out for the count. Good thing we have a probe core aboard this aircraft and we can still maneuver it and land it safe. There we go. Wakey wakey, Derek. Hope you enjoyed that. Now all we gotta do is bring him back home safe. Something we have done with this aircraft lots and lots of times before. There we go, Derek, don't worry. Hope you enjoyed your ride. We're going to bring you back home safe. Touchdown. Not bad at all. In addition to these, we've got Gilly Amusements going on. We've got Lindley and Sisger Kerman here on Gilly Amusements 4. We have an open seat here because we also have a rescue contract above Gilly. We're going to pick up an engineer floating in orbit there. I don't know how these folks are getting the engineers out there, but they are. Since we don't have to return them for a few years, though, I figure we'll drop the engineer off at the Gilly base to help with the refining of the ore into liquid fuel and oxidizer. We can complete that Gilly base contract finally. But even so, this launch is pretty routine now. We'll get these guys up into low Eve orbit, and we should have, once again, plenty of Delta V. Right after this, we'll be launching Gilly Amusements 5, which will feature 2 additional tourists and Valentina to get some additional flight experience. Finally, it is time to begin constructing our single stage to orbit craft. We're going to start with the Mark II inline cockpit. It should be the safest. There we go. We're going to need the JX5 Beelzebub turbo ramjet to get those high speeds in the upper atmosphere, and the shock cone harvester to supply that engine with explodium vapor. And there we go. Now, we don't need anything out of heavy aerodynamics. What I do need are these wing parts out of experimental aerodynamics, the Big Ox series of wings. We need this because we need to cram oxidizer in as many spaces as we can. So we have to research heavy aerodynamics, and then we can get experimental aerodynamics. Now it's finally time to begin construction. Single stage to orbit craft mathematics, courtesy of Thrimm Aerospace. First, you build your payload, such as cockpits. We got our Mark II inline cockpit. Then we need to construct enough fuel tanks and engines to get low Eve orbit speed, which in this case is 3,200 meters per second at 60 kilometers altitude. So first we need fuel tanks and engines to get at least that much, and we've got Kerbal Engineer down there giving us a delta V calculation and a thrust to weight ratio. We need a thrust to weight ratio of greater than 1 and delta V equal to or greater than our target speed. Let's see, we'll start off with a pair of aerospike engines. Where are the aerospikes? They're on the bottom. There we go. So, come on, get that thing attached. There you go. 3,700 meters per second and a thrust to weight of just greater than 1. If we could somehow get this craft to 19 kilometers and moving at a kilometer per second, then we could take it up to orbit. But that's not going to work out at all. We need wings, we need control surfaces, we're going to need all the resources to get this hunk of metal up that high and that fast. Even as we begin piling on wings, look at that. Even an empty wing brings our thrust to weight to below 1. We've got a lot of work to do. So what you got to do is, as you pile on components, these wings, control surfaces, other bits and bobs, you'll find that the rocket delta V and thrust to weight will change. So we'll need to add engines and add tanks as I go. And we'll get to watch the majority of the process here. We're finding that, well, sure enough, those 2 aerospikes are not going to be enough. Let's at least get the basic plane-shaped thing put together, though. at least get an idea what we want. You see, I'm attaching wing parts to other wing parts. That way I can adjust the entire wing without having to move individual wing bits. See, just like that. So let's start piling on some tanks. Get some more arrow spikes on there. Okay, that's better. Thruster weight's back up and delta V is back up. Let's see if we can't put a few more tanks on there and get our delta V up a little higher yet. Okay, not bad. Oh, we put our wings back on and we have just dropped thruster weight back to below 1. That's not good. We're going to need stronger engines for this. The next step up would be the LVT-30 Reliant. They're a slightly heavier engine with slightly more thrust. There we go. Thrust to weight 1.28. Delta V dropped a little bit. They're not as efficient an engine, but that's okay. We still have more than 3,200 meters per second. And we can cram a few more tanks on there. Thrust to weight is still above 1. That's good. And delta V is up. Let's continue building out the rest of our aircraft. We're going to put on some canards. Again, we are using the big Ox wing parts almost exclusively for this because these wings carry oxidizer in addition to being lifting surfaces. That'll save us from having to put extra oxidizer tanks on here. We're going to put these control surfaces up here to act as flaps. Okay. Looking good. We're still thrust weight above 1. We're still delta V above 3,200. That's good. Time to get our shot cone intakes on there and the engines that will take us up to 19 kilometers and 1 kilometer per second. Okay. Thruster weight's beginning to drop. Then I realized, wait a minute, we can't just do this all by itself. Let's make it useful. We'll make sure we can bring a payload up there. Let's just stick kind of a placeholder payload in there. Let's see, where's our decouplers? Okay, our lightest decoupler there. There we go. Let's attach a fuel tank to that we can use as a test weight. There we go, FLT 200, that's about the right size. At least on that we can attach a probe core, solar panels, other bits and bobs, and an engine. We could turn this test weight into a fully fledged spacecraft. Now, we actually got thruster weight still above 1. That's good. Delta V is still above 3,200. Let's start piling on some tailplanes. Again, we're using those big Ox wings for that. We're getting pretty low there on the thruster weight. And I haven't even attached my explodium breathers yet. 1.02, 1.01. Okay, well, let's see if we even have a usable aircraft. No, we are not very stable, at least not at that altitude and speed. Maybe faster? Not much better. So I borrow a little trick from Aerogav. We'll put some built-in angle in these wings. Now watch this. I adjust the canards a little bit. Look at that. It shifts forward just as I tilt those canards up a little bit. So I'm going to have to bring the center of mass forward. We still are not a very stable aircraft. We're still high enough thrust to weight though. We are still having enough delta V. Remember, thrust to weight on Eve would be 1.7 times that of Kerbin. So make sure you got the body selection set to Eve in Kerbal Engineer so that it calculates correctly. We are missing something though. The thrust to weight is not going to be enough, so we'll just have to go get the ultimate 1.25 meter engine, the Vector liquid fuel engine. All that science that we collected from Gilly is paying off. Look at that. Just 2 vectors and our thrust to weight has doubled, but look, our delta V has dropped to like nothing. Those engines are very, very massive. Fortunately, with a thrust to weight of over 2, we can just pile on fuel tanks. And there we go. Now we can finally hook up some explodium breathers. Those are the JX5 turbo ramjets. Our Delta V has dropped a lot. Oh, and don't worry about that first stage only saying 24 meters per second. This is a problem with Kerbal Engineer. It does not recognize explodium vapor as a massless propellant. The folks who develop Kerbal Engineer are taking a look at this, though, so that they'll be able to allow for this. In the meantime, we just keep that information handy, though, because it will prove useful as we get into flight. Definitely going to need more explodium breathers. There we go, 4 and 2. Thrust to weight has just dropped ever so slightly. Well, here, we could put some more tanks on there. And Delta V is now up a little bit, and it's up a little bit more. Thrust to weight is still above 1. That's good. That's very good. Now we just need to load up some explodium. Here's the Mark 1 oxidizer fuselage. That will give us the fuel of sorts that our explodium breathers need. This is backwards from a regular jet engine. These jet engines burn oxidizer and grab the fuel from the atmosphere. Let's get some nose cones on the end of those tanks there. There we are. I want to try to get as much oxidizer as I can get away with, and then I'll burn it all up. By the time we get up to 19 kilometers, those tanks will be empty, and we should have our thrust to weight and Delta V at the right values for when we ignite those vector engines. I think we've almost got it. Let's see if we can't fix these control surfaces. Like, we can turn yaw off for the horizontal ones, we can make sure yaw's the only one on for the vertical ones. We can try to adjust the center of lift. And then I find, well, we still could use a little bit of battery power, so I grab the Z1K batteries. That'll help so we don't lose reaction wheels high in space. Start piling on our landing gear. Okay, thrust to weight is just above 1. Delta V is more than enough. This craft should make it, assuming that we can get it up to that altitude. What I'm doing here now is I'm adjusting the tank priorities and adjusting auto struts for all of these parts. I don't have any regular struts attached. I want to try to keep the part count down. I'm also setting the fuel flow priorities of all of these tanks and wings so that the fuel and oxidizer drain from back to front. That way the center of mass should stay roughly unchanged for the flight. There we go, auto struts. If we do need real struts, we'll put them on, but we'll try auto strutting first. I've also set those explodium harvesters to be deployed right away so we can activate them by staging. Let's fill up those oxidizer tanks. We'll fill up the wet wings. How much further before we got this? Not bad. Okay. We got a very, very, very heavy craft here. Fortunately, in Eve's lower atmosphere, it's so dense we should get plenty of lift. And then it won't matter because we'll be emptying many of those tanks. We'll stick a probe core in there for testing. I don't want to risk any pilots yet to start. And one more little trick here. I put a lightweight object near the center of lift, and then I can compare it to the center of mass. The center of mass will be the exact center of the camera, so I can tell if we're going to be stable or unstable, and I can shift fuel around, or oxidizer around perhaps, as needed. You see, as I load the tanks, the center of mass is shifting. Let's get the pilots out of there, and we will get this craft out onto the runway. Interesting design for this little craft, isn't it? There we go. We got those Beelzebub engines getting this thing up to high speed pretty quickly. I got flaps out to takeoff extension. Dynamic pressure's already getting pretty high, but this is expected. This is Eve. Let's try to not go over 40 too much if we can help it, although I find later on we just can't help it. We're going to be pushing this thick air really, really hard to try to get some lift. Unfortunately, these jet engines get more thrust in the lower atmosphere. It's just like the Zephyrus turbofans. They're not quite as powerful as the Zephyrus turbofans are at the lower altitudes, but it's enough. Okay, we gotta try to get more speed though. We have to try to balance climbing with speed. Maybe the thrust to weight on these Beelzebub engines is not suitable for getting it up to even 10 kilometers, never mind 19. We're getting some pretty high pressures there. I got the flaps extended out to 2, but I'm worried that we don't have enough lift. And look at that. We lose the flaps. Way too much pressure, and we cause an aerodynamic failure, and we even lose one of the shock cones. Let's try this again. I found if I could get up to 10 kilometers and then dip down a little bit, I can pick up enough speed that I do get enough lift. I'm a little worried though that we might just lose our flaps again. That's going to be a concern when we start taking real crew and real payloads up. Look at that. Aerodynamic pressures aren't awful. They're still very, very high, but we're getting our lift back, and we're only at flaps 2. That is good. So the next step is to get this craft up to 18, 19 kilometers up and try to get a surface speed of about 1 kilometer per second. Then we'll let those vectors do the job. Now, again, the Kerbal engineer readouts do not quite understand explodium breathing engines yet, so I'm looking at the stage 0 delta V value. When it starts decreasing, that's when I want to fire the engines, but when it's increasing, that means I am burning oxidizer and I'm lightening the mass of this craft. So delta V is actually increasing as we get more altitude and as we burn off weight, but now we are starting to lose delta V. We're going to have to ignite those vectors pretty soon, or we're going to have to abort this launch. Ooh, less than 3.2 kilometers per second. I take my chances anyway. We've got just a probe core aboard. Not too bad, not too bad. There we go. We're on the vectors now, and pressures are still pretty high. At this altitude, it's much like Kerbin. There we go. We've got very, very low densities now. We're relying on those vectors and their vectoring ability to help keep the nose on this craft pointed straight. We do get an apoapsis of 61 kilometers. That's out of the atmosphere. And we're high enough up that it's going to stay there. It's not going to be too draggy. Look at that! And we still have about 450 meters per second left. I don't think we're going to need more than 350 meters per second to close our orbit. That should be enough to return the craft as well. Look at that! We're going to get this craft into orbit on just the second or so try. There we go. There, our first single stage to orbit craft. There we go. We'll drop off our test payload. Don't worry, we're just going to undo this flight anyway, assuming that we can bring this craft back safe. There we go. Give it a bit of a nose up to push that fuel tank out. Look at that. We took a 1-ton payload up to orbit, and hopefully we can bring it back. Until then, I'm not Manly. Fly safe.